Hello, Reliability Gang. Welcome back to another episode of the Reliability Gang podcast. Hope everyone's keeping well. With the man of the moment, Will Crane. How we keeping, buddy?
Good, thank you very much.
We got the endorphins flowing. We hit the gym this morning, didn't we, before the office? Had a bit of a workout, with a pump. The sun's shining. I feel like summer's on its way, and I feel like, I'm feeling...
It's going to be good.
Feeling better within myself in general. Do you know what I mean? Also, it's been a crazy week. Just got back. I'm just still recovering, actually, from Austin. That was an absolute wild experience, to be honest, at Accelerate. So big shout out to the guys at Fluke for inviting me, and lots of fresh new ideas to bring back into the mix, which got me thinking, actually, which has kind of drove us into this new podcast. So lots of really cool technology that we're seeing with the vibration analysis stuff that Fluke are doing. And it got me thinking, actually, because we've kind of really tried to cater the vibration model to be able to say, how do we get and extract the biggest value? And I think for us to be able to do that, today we're going to talk about vibration analysis and how can we utilize that technology for different companies and extract the value by different ways of doing it. So whether that's us doing it handheld every single month and coming in as an actual expert and specialist, empowering people to do it themselves in terms of data collection, maybe we can analyze the data. And also, how has technology been able for us now to unlock these ways of doing things? Because I do believe that 5-10 years ago, this was a lot more difficult to do because A, price point was really difficult, but not even that. B, is mentorship and knowledge and teaching has changed within
massively
that whole perspective as well. So Will, give me a bit of introduction into the evolution, shall we say? I mean, even the evolution of us and vibration. But that's it. I think all we have to do is explain our journey, but also explain to us how technology kind of maybe 10 years, even actually maybe stated from when you first started to maintain to how it's evolved even to now. Because I think that's kind of a decade, isn't it? It's roughly about 7 years, roughly, you know?
I mean, even when I was at British Sugar beforehand, I think that the general concept of vibration analysis for many years has been handheld data collection.
Yeah, it has kind of been the king of that, hasn't it?
And it still is a very cost-effective way. When we talk about vibration analysis, obviously there's different ways we can acquire that data now, which has been evolved quite massively, from wireless sensors to handheld data collection to continuous monitoring to protection systems. There's lots of methods of acquisition, but I think what we're kind of talking about a little bit with vibration analysis is understanding kind of what is it good at, what is it not so good at, why would I need to acquire the data differently, and what that means. And I think definitely...
And also, you say what it's not good at. Where is it giving a false sense of security with certain things that it's not actually detecting some of the things that we're trying to do? Like a lot of the time I do see a lot of companies trying to over condition monitor things. And it's like, mate, this ain't going to find the problems here. We need to do some root cause and defect elimination, because what you're doing essentially is trying to find something that it can't find. You know, that happens as well, doesn't it?
We see it a lot of the time, especially from like the problem is you have to get into the technicalities of vibration analysis to then be able to evaluate whether it's suitable or not. And so particularly we see that with wireless sensors, they have more limitations than say handheld data collection has. Continuous monitoring is very effective, but then you lose the engineer at the machine, but then you gain lots of trend data and lots of ability. Yeah,
and I think this podcast is going to be more about is educating people and giving awareness to what systems are available. Because again, there's systems, there's something for everything out there. But the problem is what really actually fails is not the fact the vibration analysis is not working. It's the strategy to understand what equipment we need, what frequency responses we need to capture, which is more kind of driven off how that machine can fail and what we're trying to see, right? And
I think that's probably the first really good starting place for anyone listening is some basic vibration analysis.
Basic principle. Let's go back to VA level 1. We said, you know,
the two things that massively affect, I think, vibration analysis across the product space when it's wireless or wired or whatever is how long can we acquire the data for? So the time waveform, which is the raw signal that we're collecting, we can change the parameters to determine how long we measure for in seconds in time. And particularly for slow rotating assets, we want to be really aiming for 6 to 10 rotations of the shaft, right? Yeah. And so therefore the system that we're choosing, whether it's portable, wireless or whatever, depending on the rotation speed of the shaft with the bearing, with the gears that we're trying to monitor, we need to ensure that we're able to measure long enough to capture that number of rotations.
And that's a great point as well, just to add to that, in regards of knowing that if you have got applications that, are slower moving in nature, we have to make sure that we have the right resolution to be able to have that long enough time waveform to capture them events. So this is why sometimes wireless monitoring can be difficult and has its limitations, because it's not necessarily designed to draw that battery life to be able to take them longer readings. So
And your other main parameter that we're looking at is what you may see on some of the technical data sheets is what is the maximum frequency that the sensor can resolve in terms of its spectrum. And that's going to determine how early we can identify the faults and what faults we can see within the data.
So the quicker it can sample, the higher frequency, because obviously if you imagine higher frequency events happening a lot quicker, well, then we have to sample quicker the signal to be able to capture them high frequency events, if that makes sense.
Exactly. So, I mean, if you have a shaft that is rotating at, let's say, 25 hertz or 1500 RPM, so it's like an input shaft on a gear, and you had 10 teeth on that gear, we would expect to see a gear meshing frequency of 250 hertz. I'm not going to do the 1500. What is it? 15,000 cycles per minute.
Yeah,
I think
times by 60.
Yeah, if your frequency range is less than 250, which is very low in real spec, but if it was lower than that, you wouldn't see it. You wouldn't see it. That's the principle there to understand, is that we need to make sure is that the issues that we're trying to identify, and I think for bearings we're looking for, what is it, 6 times the fault frequency harmonic we want to be able to see.
I think for envelope what you're trying to see is the fourth harmonic of that bearing. Really, that's what you want to see. So for inner race, that is more higher frequency. And this is another thing as well, what we're doing, like we're saying, right, we're going to set our system up to be able to find or see the picture where the faults are going to lay within that frequency range. And that's what we need to try to do it. So when we're looking at strategy and setting the database up, what we don't want to be doing is measuring a stupidly high frequency. So all of our frequencies of interest are down the bottom. We want to be able to really window between exactly where we're going to see the last particular frequency of interest that we're interested in. So this also is how band alarming does work, and certain different fault conditions will appear within the spectrum at different frequencies. So ones that we are particularly interested in or we know are damaging to the machines that we've got. So say, for example, you've got a straight couple machine, we want to be able to potentially see the 2 times, running speed frequency for misalignment is one of the fault indicators that we're trying to look at. Maybe you want to see that in the envelope as well, because it's going to be able to see if there's any coupling stress. We're able to signify where we really want them band alarms to tell us what problems we could have. And this is, I think, a really important thing to do within vibration analysis. We need to lead it off the failure modes of the machines we're working with. Whereas I do feel a lot of the time it's like, vibration, we'll just put loads of sensors on everything. I'm not saying that we're not capturing the frequencies that we need to, but if you're not really pinpointing what you want to see, if that makes sense, this is where you're going to not have the clarity about how to make the best decisions within your maintenance functions. Because your alarms might be going off, but you have to also remember sometimes a low level alarm at a certain frequency is a problem. And if you're not actually trending that and actually looking at them certain places, the vibration is just a vast spectrum of information coming in that doesn't actually mean anything until you put meaning to what you're trying to find. And this is also what we're trying to evolve into now as well as a company, because it's not a case now of just saying, you've got 100 assets, we're just going to test 100 assets. A lot of the time we are, even the handheld data collection model is really outdated in the sense that a very high critical asset is getting the same attention as something that could be run to fail. So how are we doing, how are we actually now assigning, in terms of criticality, the equipment, and how are we actually prioritizing, putting more effort or more kind of monitoring on the things we want to find? And this is where it's evolving, I feel, because 5, 6, 10 years ago, online systems inherently were expensive. You know what I mean? It was the cost at entry was very difficult to be able to justify. So this is why handheld vibration analysis was so good, right? Because you was able to come in and you was able to get a very good sweep, and albeit you might only be taking a reading every single month, you can still find some great problems with that, right? The one problem and limitation that has, though, especially on complex machinery, is a snapshot in time. And to make a decision on such a critical piece of equipment, we sometimes struggle even on a monthly data as well when we see it go up.
Especially for us as well as contractors, where we do have to make a decision within that snapshot.
That's what you're paid to do, right?
We have that one opportunity we've got to make. We don't have the ability to go, oh, we'll go test it again tomorrow.
Yeah, well, I'll go my data collector and go tomorrow. So this has also, got us thinking as well, because now we have a model with some of our customers where they collect the information, is when we do find a problem or they find a problem with their alarm sets, is like, okay, we're going to take it every day now for a whole week.
This ties into, there's a piece I want to come to in a little bit around sensors and AI, but I'll come back to that in a little bit. But I think what would be really good is maybe we can bounce off each other a little bit between portable data collection, maybe wireless systems and continuous monitoring. What are the pros?
What are the cons
of each of those? So obviously, portable data collection, we'll bounce back and forwards, right? Obviously, portable data collection, we have the capabilities to have a very wide frequency range.
Yeah, good. So high quality data.
High quality data, high resolution. We have no limitation on the shaft speed whatsoever, and we can tailor those measurements whilst we're there.
Yeah, 100%.
Real important pro,
That's a good one. Another pro of data collection, you can collect a lot of, now obviously technology and data collectors has advanced as well. It's a lot quicker now to collect the information and data. You can cover a lot of assets within one day. So value-wise, within a day,
it's cost effective.
It's cost effective, 100%.
Yeah, portable data collection. Okay, so a big thing with portable data collection that you're not really going to get in either continuous or in wireless sensors is you have got a technician at that machine. So if they see anything in the data that is abnormal, they want to take an additional measurement. They want to change the measurement parameters. They want to have a look and a feel.
They want to do some more troubleshooting. Maybe.
They want to troubleshoot. Right. They can do it there and then at the machine.
Exactly. And, to add to that, if they want to do any phase measurements with, a couple of single axis sensors, they can go there, troubleshoot a little bit, get a bit more clarity. And again, observations, they can see an oil leak. Sometimes
they can hear what's happening with the machine.
Exactly. So there's being there and being, doing the analysis by the machine. Sometimes that enables an expert to be able to dig a little bit deeper, even with not having a few readings in time. You can use your sensors around it that allow you to be able to make a better decision and close the loop on what the decision needs to be.
And I think there's a lot of positives to data collection with Handheld. There's not many cons to it because we have so much capability within the data. But I think the biggest con with portable data collection is the fact that the skill set that is required to collect the data is somewhat limited.
Yeah.
Like you do need to know what you're doing. It's not the easiest subject to learn, and it's not something I'm going to go on a training course and suddenly I can go collect data and I know what I'm doing.
Exactly, yeah. And I think obviously there's two parts to it. I think with the training, it's becoming a very good observationist, I say, and good data collector of understanding, well, where do I collect the data from? If I get a high reading, do I collect more data? What do I look for through that process? That can be taught, to anyone, to any engineer, really, to be fair. But again, it's so important that that's done correctly. Get on to the reasons why when we get to...
And I think that you have to look at like data collection, whether or not you have a contractor coming to do it, or maybe you have built up some capabilities to do in-house. There's two parts to that. Like, are we treating going around with the vibration analyzer as just data collection? So is your current service provider just collecting the data in the zone, or are they analyzing as they go, doing additional tests? Ideally for us, we've done it for a number of years now. I was with a customer the other day explaining the concept. I said to her, realistically, I'm not leaving the site not knowing what the issues are.
100%.
I know what all the problems are before I've left site.
Yeah, and you've got you had that conversation with with the engineer manager on site as well. They're aware of everything that you've found. And, you almost care for the site like it's your own, because you're on a mission there to find the problems, and that's what you're paid to do. So I do feel like there's a huge value in having that, because what you've got now is that person is almost looking to find things, and an eagle eye out there. They're not fault blind to the plant because that's what they're there to do.
I suppose, though, a really good, this is a good con. I say good con, there's no good cons, but it's a good point to make around portable data collection is, in general, from a expertise perspective, especially like for us, we send our engineers, and generally we've taught them to be able to analyze the data. We don't tend to send data collectors. from sending high level vibration analysis, typically all our guys are level 2. In general, it's quite inefficient.
Yeah.
You've got maybe 100 assets, 10 problems.
Yeah.
And that engineer is on site collecting data for those 100 machines where only maybe 20% of them require that level of analysis.
I agree. I think that's a really good one. I think and as well, I think for me is the limitation of when you're on site again. I think that's the biggest operability as well. So if you come to site and say, for example, a lot of the plant isn't running that day, or there's an issue, or there's a problem, or there's a batch process issue, so you miss half the critical assets, you're really defined on the randomness of the process on that day, whether you can collect data or not. And I do think that is a bit of a con when it comes down to it.
But I think you can also flip that into a pro, which is if you do have variability and you have an engineer on site, they can work with the operations team. Like, oh, I need to test this at this point.
Can we get it running?
Can we get it running? Can we do this? I mean, I was at a site in Germany, and they have these machines that go through different processes. Well, I was able to plan my day around the fact that I need to test it at that point in the sequence. I need to test it at that point.
Yeah, I agree. And I think if it's planned, it can be highly effective.
Yeah.
But also another drawback is when you do plan it and a customer hasn't maybe planned it in or whatever, you can come to site and, no, my data collection day is kind of ruined because of the... So with planning, it can be highly effective. And in general, this is, I think, why, I mean, there's lots of pros there. This is why generally now...
I'm struggling to think of some cons.
I know, and we're trying here because this is generally why...
I'll tell you what a good con is, actually. For us, it's our core business, right? But we're doing a lot more now in building capabilities for teams so they can understand it.
We're evolving.
We're going to come on to that a little bit later. But it's generally speaking, if we're talking about analysis at the machine, it's a high cost to entry.
Yeah.
Data collectors are expensive.
They are 100%. So for service providers like us, this is why we have to charge the day rate to cover the cost. But you're right. I mean, a high grade analyzer is still probably 10 grand plus, depending on what manufacturer you use. And even more some depending on higher ends of the manufacturers you use. So yeah, doing that, essentially, even yourself as a site, there's still an outlay of cost to be able to, before you get any value back, to be able to go into there straight away as well.
I say it's a high cost to entry. I mean, we're going to come onto wireless in a moment, and we're going to come onto continuous monitoring. It's actually, compared to those two, very cost effective.
It is, yeah, 100%. So this is why predominantly handheld data collection is still widely adopted now, because the cost of doing it in terms of value of what you get back is very high. Do you know what I mean? A lot of sites that do run very often, do you know what I mean? You get the value out of monthly data. Generally, wear related issues within every single month, which is generally kind of what we do. I'll be honest, 95% of the time, you're gonna win. Like, we've been doing this a very long time now. Do you know what I mean? With lots of our customers, and very rarely you get a failure that's wear related that you don't see between a monthly window. A lot of the time, when the failures do happen, they're generally random. They're not really a wear related event, but there is a risk there as well with them wear related in between them surveys, which we'll get onto some of the points now. But I think we've kind of wrapped up.
I think that's portable data collection.
Yeah. So
wireless.
Okay, let's go into wireless. So pros of wireless data collection: ease of install.
Yeah,
it's gotta be number one. Like, I think this is where everyone loves a wireless device as well. Like, when you get your wireless headphones, there's no lead. I don't have to plug it in. I'm free. So I think we have been conditioned a little bit with a lot of the wireless kind of other technology features that we've kind of benefited from personally in the past. Yep. And I think that's why it's quite nostalgic. Oh, wireless sensor, we put it on, we connect it up.
No leads,
there's no problems to have. And yeah, this is great. But there's a huge con to that whole element of, it's really easy to install, because with wireless, you're guaranteed to have some form of connectivity issues. Just like your wireless devices of like, why won't my wireless headphones connect, for God's sake? So with the big pro of the ease of use of it, there is always a connectivity issues as well. But again, I think we've found that some manufacturers, you have less problems.
Some you have
a lot more problems with as well. So it's 100%. Also finding the right kind of supplier. But also, what's really important is to understand how that wireless technology is being connected. So is it a mesh network where the sensors talk to each other? is it a different network where a central gateway, every sensor's independently talking to that gateway? Depending on how your site is set up in terms of where you want to place these sensors, it's going to be highly dependent on whether it's going to be a feasible option for you or not. One thing I really dislike about the wireless industry is it's sold on the pretense that every single application, there's always a way around it, which in some cases, there isn't. We've had applications where that's just not going to work. That's not going to be sustainable for the client to be able to get reliable data, because we also have to remember, if we're relying on this information coming in, right?
It needs to be reliable.
We cannot be, sensors disconnected again.
Yeah,
we've missed a huge portion of an area of time where that would have been so valuable to capture it, or something fails because it's not managed to be able to ping the data across, or it's poor at communicating. There's a problem with it. We've had a lot of systems where there's no alarm to even identify when the system's not running. So it's like, everything seems to be okay.
So suddenly it's all just dropped out and nobody knows anything about it.
So we don't have any indication of exactly when it's dropped out. And it's little problems like that. It's like, it's such an important thing to have. And, this is where the cons can really start to build up as well.
We'll try and not make it too like we don't like wireless, but there's a place for it.
I think there's a place for them. But again, I think the problem is when you're really looking at strategy, and you're really looking at the failure modes, and you're looking at how do I protect this asset in the best possible way, then you look at effectiveness in terms of how we actually apply it. And this is going to be very evident in this study. So this is almost like its own little case study to identify to everyone of where these fit within the industry, and also how does Mind and Will's thought process actually go through? Because when we're speaking to customers, we're not just trying to sell them something. We're not just trying to look. We're service providers. We're different. We're not here to
solution providers.
We're solution providers. That I love that. We are. We're here to be able to say, well, what's the best solution for this customer? We don't want the problems. We don't want the customer saying
it's not working.
Sensor disconnected. So we're also thinking about what is the best way that we can provide a solution to this with least amount of impact and problem to our operations. Does that make sense?
I mean, like, let's think of as well with wireless sensors, what are some that we, triaxial. Okay. I understand though that it's triaxial at the point where the sensor is. So it's not necessarily true vertical and true axial, but it does give you 3 axes of vibration.
And it can be handy.
Be handy. Most of them come with a temperature output.
That's really cool.
Really handy.
Yeah, cool little metric to have,
Like you say, ease of install is really handy with them, particularly harsh environments or where it could be very expensive to run cabling.
Yep, 100%. In accessibility. Yep. So if you've got an actual fan that is up in the voids that you can't access, and running a cable run to it is just like, well, where am I going to run a cable to? Like, I haven't got 10 miles of cable, and it runs all the time. That for me is a perfect use case, because 2 sensors could solve a great solution. Yep. And even if it takes a reading a day, you've got some good trend there, haven't you? Do you know what I mean? Let's be honest, it's a lot better than having one reading, shall we say, over, say, for example, and here's another pro of a wireless data collection. You do get more information. You do get a bigger picture of the trend, right? And you might be able to see a little bit more of an earlier indication of a defect initiating, which is handy.
We know we have things happen in between our 30 days. A lot can change in that period of time.
Exactly. And some of that info could really give an indication of a change in parameter that a customer would want to know about. Do you know what I mean? So that there's definitely a pro with that. And, if you can take, 30 data sets within a month, you've already taken more data essentially over 12-month period, if that makes sense as well. So I think the trends, what you can pick out from it, and we've got a few wireless sensors at a couple of our customers as well. It's really nice to see the trends.
It's just nice to have a bit of a gap fill between the data.
I totally agree with that. You know what I mean?
Right, cons then. Here we go. Strap in. Frequency range.
Yes, frequency response
tends to be limited compared to continuous monitoring.
Don't get me wrong, there are sensors out there that have got a higher frequency range, but then you're really looking into high costs. Yep. But then there's another con, because you have a high frequency range, it drains the battery. Yep. So now you're only limited to maybe a reading per day, for example.
Yep.
And, if you want more of a continuous kind of monitoring system that looks at process parameters as well, you lose that by doing that. Then now it's not really considered a process kind of monitoring point, if that makes sense as well.
I think the other main con, so for people to understand, is that the majority of the wireless sensors, I'm going to say, are dumb in how they work. So they are not smart enough to understand what the machine's doing, what it's doing at that point in time, what else is happening within the environment. They simply sit dormant on the machine
And say, oh, hello,
and
I'm
wake
awake now.
up at a set predefined interval, and then they decide whether or not they're going to gather that data or not.
Yeah.
If the machine's not running when it does that, it's collecting the data with the machine off. If the machine is working harder at that moment and the trend is higher because it's under more load, it knows no different.
It is just collecting data. That's what it's doing. It's not learning, shall we say, off the parameters or any process input parameters that we've got, which we can do with continuous, which we'll get onto in a bit. I'm trying not to overlap here with some of the things, but it's more comparisons. And this is where they're very different systems. And this is where I think it's really important for us to explain that if you are got a wireless system and you've got something that's continuously powered, they are different systems in how they operate completely. So this is why when we do strategies and we are seeing, you know, assets that have different variants of load and variants of speeds and stuff, wireless sensors has always been a very difficult system to track that and understand exactly when the loads are the same and when they're not.
And even some sensors on the market do have the triggerability function, but most of these sensors are just communicating at a regular interval. And at the time of interval, if it matches the trigger definition, then it decides to store the data.
And that's what I think, that's where the technology is trying to go with the wireless sensor options. This is why we're not seeing piezoelectrics within, you know, sensor setups anymore. We're seeing MEMS based sensors as they improve.
The battery life is too much.
It's battery intensive. So I think the idea is eventually, and I know there's sensors out on the market that are trying to, you know, be able to be mag flux and harvest and be able to take that. I do think I see a place eventually when we can have that working very well, but right now, currently, they're not at the place.
Which ties in perfectly the fact that you're saying, oh, we can see that in the future. This hardware and even software obsolescence happens incredibly quickly.
So that takes me to my next con, obsolescence. So if you have got an invested in a system that, you know, maybe was designed 2 years ago, technology moves so rapidly fast. And if you have installed thousands of sensors on your plant and spend that money, I could probably guarantee 2-3 years that there's going to be a better iteration or modification of that sensor, which happens within all technology. And you're probably going to have to potentially buy the hardware again. So,
especially for some sensors that don't have battery replaceable functions, so they're throwaway. Some sensors do need to have their battery replaced, and we know that we've got working with one provider who is asking our support because they've got well over 100 sensors and all the batteries need replacing, and the site themselves do not have the time to go round to all these sensors.
That's why we rarely sell people just sensors. We will not do it because we sell them the sensors and then they'll go obsolete. Like, generally, if we're going to do the model, it's an OPEX model. We'll put them on, we'll be the experts, we'll analyze, and we'll sort the rest out because the other options not sustainable for the customer. Do you know what I mean? It makes no sense to be able to write off hundreds of thousands of pounds of hardware because you've had updates and upgrades. It makes no sense financially.
The thing is for the companies developing the sensors, you know, they'll still support them. The data is still going to come in. But it's then, I've got the old version now.
Yeah, but not even that. Then you're restricted to new features that are going to add you value in the future. Does that make sense?
Yeah.
And that is the problem with this. It's like an investment. It's like if I buy a car, do you know, I want the latest model, right? I mean, how annoying is it when you buy a model or you buy something or you buy the latest Apple AirPods and then next 2 months it's like Apple AirPods 5 for that and you're like,
we had one where we had version 1 of the sensors that a customer had installed, where they actually were sold by another provider and asked us to come in and support them. Version 1 sensors, version 1 gateways. The company had bought out version 2 sensors, but version 2 sensors couldn't communicate with version 1 gateways. They could only communicate with version 2.
It was a nightmare.
It was
absolute nightmare. And I can see obviously sensor manufacturers are going to innovate, aren't they? Of course they are. Everyone needs to. But again, what is the impact of innovation? We've got to also have a look at that.
We're not at a stable point when it comes down to wireless sensors. When we come on to continuous monitoring in a bit and even handheld data collection, standard is 100 millivolt per G accelerometer, which has been the standard
so
for
reliable as well.
15, 20 years, even longer than that probably.
And that's where we'll move to, continuous monitoring. And I think we'll start at that point there. You know, piezoelectric 100 millivolt per G sensors have been the go-to for vibration analysis for years.
Decades.
And now, we can even make them small. And you look at the small little piezoelectric sensors we can make now, there's tiny little capsules that Chris does at, Handheld. Even if we need to have a really small form of that particular sensor, we can do it. But generally, in general, the sensor size is fairly small. It's very low profile. So this is another big pro with the sensor, that you can get a very good frequency response from the sensor. Some of these wireless sensors, when they first were made, were disgustingly big. I mean, you look at the resonance curves of some of these sensors that were first made. Do you know what I mean? Remember the big square block ones that they used to hang off machines and stuff like that. I'm not naming any names, but you look at that model, it's like, because you need a huge wireless transmitter, right? Whereas when you get a nice piezoelectric sensor, you can put that sensor in the loaded zone very nicely. So mechanical transmission with the high frequency response of that sensor allows us to get the highest quality data.
And we didn't mention with wireless sensors, but it ties in nicely. Wireless sensors do have a big limitation when it comes down to slow speed machines.
Yes, 100%.
Huge limitation. Now, when it comes down to continuous monitoring or even handheld data collection, we have the ability to, because the sensors are hardwired, we can gather very long time waveforms if we need to. But also we can, say, put a higher sensitivity sensor on it.
Yeah, of course. We can go say if we want a different sensitivity depending on what we're monitoring.
Particularly if we're monitoring something very, very slow, 2-3 RPM, we might have
amplification,
500 millivolt per G. Or if we're measuring something with very high shock loading, a big crusher.
And you're like, right, I need to reduce the sensitivity.
I need to reduce the sensitivity.
100%. So you have that option depending on what you're monitoring, which I love. And another great thing about continuous monitoring, this is probably for me the number one reason why I would suggest them, is its ability to be able to monitor practically anything. Because you're constantly monitoring a parameter or something, or you're measuring, and you can have lots of different outputs and digital outputs, and you can measure different process parameters, vibration, temperature, current. You can trend all these things, but even more importantly, you are able to stabilize the data or stabilize the machine running conditions at certain points. That allows us to trend very tricky machinery like CNC machines that we're doing now in terms of going into CBM modes.
Even refrigeration compressors, right? So we do a lot for a company. They've got a lot of ammonia compressors. We're now coming towards the summer period. We'll see all in our handheld data. We'll see all the alarms start to increase as we get to summer.
Because there's more load.
Working harder. They're trying to cool the freezers a lot more. And then as soon as we get to winter, we start to see them drop off again.
Exactly. And what we can do with that is do very smart alarming to be able to say high and low alarms to understand exactly where we're at.
Because at the minute, for the engineers, from their perspective, we can't just like, we're bumping them up because it's summertime. We're dropping them down. Whereas actually, within some of the continuous monitoring systems, we can do that.
Yeah, we can see that.
We can set a outside ambient temperature. We can adjust the alarms with the outside ambient temperature because we know the machines are working harder or they're not.
And we've got that comparative data now to be able to make them models. And that is another good thing about wired data collector or continuous. There's no limitations on how much data you collect.
You can get
the only limitation is how much data you store. But if that's valuable, and let's be honest, data storage now is cheap. It is. Like back in the day, it wasn't so much cheap, was it? Remember, you used to buy a 512 megabyte bloody like Walkman, like little tiny MP3 player. I remember being in school and it was like, oh, do I want the 512 or do I want 128 megabyte?
Like, a 4 gigabyte USB stick now was like 30 quid. Now it's like £2.
It's ridiculously cheap.
You get like 100 gig USB sticks and all sorts of stuff.
It's crazy now, storage. Like again, technology revolution allows us, and it's not just one thing when it comes down to kind of like technology. You need wireless technology to be better. You need connectivity to be better. You need data storage to be able to be better. And now half of it's held in the cloud anyway. So like, again, the technology advancements have allowed us now to be able to actually have a price point where continuous monitoring is now not expensive to do.
The biggest con with continuous monitoring is you have to cable it in.
It is the install. But my argument of that is if it's critical enough, why are we not doing it?
But not also that, like I've said to nowadays as well, when we're looking at going forward, the digital plants and trying to digitalize what we're doing, no one's going, hey, should we put all our pressure transmitters on wireless? No, because it's not reliable.
Do you think they would do that?
No, they would.
And this is also a crazy thing as well. Now, the adoption of vibration has become better, but it's still poor. Because half the systems that we see now haven't got sensors on. You know, oh, can't access that. Oh, we've got a pressure sensor, but we haven't got a vibration sensor. We're not going to measure that. You know, I went to a brand new site the other day when we were doing some work in the Netherlands. You know, everything's got all of these other sensors on, no vibration sensors whatsoever on assets that are high in the
Which
sky,
we know
can't
as well,
access.
at the design stage, biggest influence, lowest cost to install.
It's tiny. Like you know, even piezoelectric sensors now, the cost has come down.
Yeah.
It's not the same as it used to be.
We're finding now, we're doing some pricing at the moment for a customer as a comparison, and the price difference between a wireless sensor install versus a hardwired install is a lot closer than it ever used to be. Very, very close.
Oh, 100%. And I'd also say is like now with that high frequency sensor in the right loaded zone, you know it's in the money. You've got constant data collection. You can see the data live if you want to. You can look at it and actually have a look at it and see what the response of the machine is doing. Once you've got a continuous monitoring system set up in that way, and you've got it set up and all the things you want to look at, all the band alarms and all, and you've got a real technical company really looking at the failure modes, there's nothing really you miss. And I think that is, if your company, for your most critical assets, be in a position where you're constantly monitoring every parameter that could potentially cause you to fail, and you're in that position, you are above and ahead of 90% of people in your field and your competitors within what you're doing with maintenance. Because I'll be honest, there's still a huge amount of percentage of factories not even doing handheld data collection, let alone monitoring that way. And
this is like overall, you know, we've talked about the pros and cons of handheld. We talked about the pros and cons of wireless. We're talking about the pros and cons to continuous monitoring. All of these just are methods of acquisition. Typically, you're going to have maybe us or a provider out there that is analyzing that data. Maybe they're collecting the data for you in handheld form. But what we're seeing as well more and more is, and I'm a big believer, and I know you are as well, in that there's not enough of me and you and our guys.
100%.
And
there's nowhere near enough.
And what we're trying to do, and I think is more important than ever, is that companies have some level of internal knowledge and capability to have some basic interpretation of that data.
Yeah, 100%. And I think that is doable. So, you know, going on to kind of the customer collecting the data on the handheld point of view, you don't need to be a vibration level 3 analyst expert to collect good, meaningful data.
And that's where you differentiate between data collector and analyst.
So there is a difference, and we have to make sure that, you know, we understand that difference if that is the model that we're going for. We have customers that go collect their data and send it us as an analyst, but we also do awareness training as well about mechanical transmission paths. Where repeatability is so important to be able to make sure we're taking the data, putting discs on the machines of saying, here's where we're collecting that and here's why. And also giving training to the guys that are collecting the data. Are you collecting that data when the machine's in a nice constant road of vibration?
And that probably is a really good con to portable data collection, is if it's not set up correctly,
it can go wrong.
I'm testing in the wrong point. I'm not testing in the load zone.
We've seen sensors that are being installed completely in the wrong loader zone positions, and we're not quite on the money. We're not actually seeing the issues and problems. And this is also, it goes back to Vibration 101, the basics of mechanical transmission path. The laws of physics does not change. Laws of physics don't change. We know that, and we have to make sure that is always the basis of where we grow from.
I think that going back to, like, we're doing a lot of mentorship plans at the moment. We've got customers where we're going in, we're teaching them how to collect the data with the long-term plan to teach them how to analyze the data, and then have us there always for support and help, right? But I do think it's really important, no matter whether or not you've got portable data collection and you're doing it yourself, or we're doing it, or some companies do it, or you've got wireless sensors, or you've got continuous monitoring. Any company that is looking at outsourcing condition monitoring or vibration analysis, or utilizing wireless sensors or continuous monitoring, someone within that organization needs to have some basic knowledge and understanding of vibration analysis, because even if you're looking at a wireless system on the market that does AI and tells you what to do, it's a very dangerous place to be in to not understand how it's getting to that determination.
I totally agree. It's very dangerous to rely on external information if you do not understand exactly how them decisions have come to. If an AI model is telling you to make a decision on a highly critical piece of equipment, and you don't understand how it's come to that conclusion, That is very dangerous.
There was a podcast I was listening to, really interesting. It was by a guy that had developed a lot of the training material in AI. And he basically said, if you can imagine, like ChatGPT, we use that as an example. We put an input in, and at the end, the output comes out of it. But in between that is like a chain link fence. And that AI model is working its way along that chain link fence to get to the end turn. We don't actually know how or what route it took. No, even within AI, we don't know the route it's taken to get to that. So obviously the models that are being built around AI, obviously there's some guidance, that's principles that are given to it, and it's taking that route and it's spitting something out at the end of it. But if you don't understand the basic principles of what it's looking at, or even if we're analyzing the data, the more our customers can understand what we're talking about when we're putting our reports, and obviously we have to be very conscious not to make them too technical.
That's the translation, right? That's the value. We're translating something that they don't understand so they can understand what's going on with the machine so they can make better decisions. And you are right. It is our job to try to bring them on the journey, and even if we give them some basic knowledge, they understand why they're making the decisions.
And we can see the value even more and more now as well. We've got a lot of customers now that are transitioning and being a lot more strategic with their vibration analysis strategy. So with the really highly critical assets, we're moving on to continuous monitoring. We don't see a lot of wireless sensors because the price point now is like, why would I go wireless when I can go continuous?
But that is also another huge thing. The continuous model is becoming now, it's doing this.
Yep.
So now it's like, well, where do I spend my money? Or do I spend it on sustainability? Or do I spend it on something that could potentially be outsourced or potentially could be superseded?
Exactly.
Like, we don't want that, do we? No. Like, if we're buying a car or psychologically you're buying a house, of course you do. Possible. You don't want to go buy, and now it's also people are like, do I buy a combustion car anymore? Because is there going to be, people want the future?
We just looked at it now. We've got this customer that they're looking at moving all of their critical compressors onto continuous monitoring. They've got some assets that are a little bit far away, and we were working out the cost going, do you know what? It's about 30 meters. And we're like, well, okay, we could put them on wireless sensors because of the distance, but we've got channels available within the system that we're monitoring.
We figure out how much
30 meters of we'll just run the cable. To have the ability to have like live data, like I can lock in and I can see.
And I get it. Labor cost can be an issue, but because we're a company that has a mechanical team that can do that easily,
we just do it while we're there.
Just do it. So like, again, it obviously depends on your resource and what you're doing. But when you're working with a company like us, we're always going to pick, it might be a little bit more expensive, but it's going to give you 10 times more value. We're going to always go with that option because we prefer go the extra mile to get that sustainability out of that option opposed to going the other way.
And we're seeing now as more, like we said, we looked at that data collector versus the analyst, right? The data collector, or the person that's able to do the observations. For us at the moment, sending level 2 or higher analysts can be very inefficient. But your engineers know your plant better than we do.
Yeah, 100%. Yeah,
they also understand how the machines operate. And we've got a lot of customers now, and we're doing a lot of mentorship and training around empowering them, not necessarily to be full-blown analysts, because it's not their day job. But if they have the capability to go to a data collector that is not maybe as expensive as a full-blown singing and dancing analyzer is, they can go out and gather the data. They can feed it into us to be able to analyze. We can be the experts. And we can be the experts.
And mate, honestly, what a great conversation. So guys, if you're looking to weigh all these options up, and the thing is with us, we don't really suggest one way. We want to really be able to give you guys the option of what's good for your plant. Of course, we can make advice and give recommendations of what we want to do, but get in touch with us in terms of getting that ready. But what an incredible podcast, great discussion. And I'm sure you're going to see.
We had to cut it, otherwise we would have just kept going.
We're gassing. We never get to 45. Like, this is crazy on one subject.
But then I think it does really show as an endpoint that, look, this is a if anyone, like, we really enjoy talking about it. So if anyone just wants to chat about it and extract some expertise,
let's have a chat. Yeah, let's do it. Let's do it. Anyway, guys, take care. Have a great week.